All right, in this video, we're continuing to look at logarithms, specifically at some laws of logarithms. And we'll use these to help us solve equations in the next section and in the last section. So, just before we go to that, a question for your video quiz. This looks like a golf course there. Sure enough, it is. Paradise Canyon Golf Course. Beautiful picture. It's a interesting sight there, sort of in the fall. And the river valley is beautifully stark, I think. When we look at laws of logarithms, you'll see that there's a very close parallel to the exponent laws. Indeed, we call them the same thing, product law, quotient law, and power law. Their implementation is a little bit different, but they're very similar. So in the product law for exponents, you're multiplying common bases, add exponents. Dividing common bases, subtract their exponents. And the power law is if you have an exponent here, you can multiply it by that one, and you get a product there. So similarly, in the product law, there's some addition and there's some multiplication. Sort of similar to what we had over here. Multiplication ended up doing some addition. We'll look through each one of these laws separately and do some applications with each one of them. So the first one is the product law, and it says if I'm taking the logarithm of a product, I can split that up. So I can take the logarithm of just the first number, log of the second number or factor, and when I do that, then I add the results. So for example, this first one, I can say, well, that's the same as log base 5 of 25 and log base 5 of x squared, and I add those two. Now this particular one, you can, and I've done this with some of the examples, you can simplify this further. So to what exponent is 5 raised to get 25? To the second exponent. So this whole thing becomes 2. So 2 plus log base 5 of x squared. Here's another one. Log base 3 of 45. Now 45 is not two things, but I could change it so that it is two things. I could write it as log base 3 of 45 is like 9 times 5. So then I can apply the product law, so that'd be log base 3 of 9 plus log base 3 of 5. Do you see what I can simplify a little further? Sure enough, log base 3 of 9 is 2, because 3 squared is equal to 9, plus log base 3 of 5. So that'd be the simplification of that last one. Why don't you try some of these? Just follow the law and see if you can figure it out. Press pause and play. So this one, I could say it's log base 2 of 4 plus log base 2 of y. And again, the first thing, I don't know why it's always the first thing. First thing I can simplify, 2 squared is 4, so that whole thing is just 2. So 2 plus log base 2 of y. Next one, things that multiply together to give you 48. Maybe 3 times 16. Yeah, that's 48. So that would be the same as log base 2 of 3 plus log base 2 of 16. If you're looking at that log base 2 of 16 longingly, thinking that you can simplify that, sure enough you can. To what exponent must you raise 2 to get 16? I think the answer to that is just plain 4. So that's a product law. Here's the quotient law. Quotient law says if you're taking the log of a quotient, take the log of each thing separately and put the numerator in the front. So for example, this one would be log base 7 of x and log base 7 of 49, and there'd be a minus in between. Simplifying, you could take log base 7 of 49, to what exponent is 7 raised to get 49? Just plain 2. Not all the questions will be able to do that. I'm not sure why the questions I'm giving you here are all like that, but that's fine. Okay, try some on your own. One on your own. Okay, this one would be log base a of a squared minus log base a of 8. This one here, to what exponent can you raise a to get a squared, it's to the second exponent. So that whole thing just becomes 2. Log base a of 8. Okay, now let's take a look at the power law. So the power law, when you look at it, the only difference is that they take this exponent here and they move it out to the front. It's quite a powerful rule. I used to use it all the time in solving equations, and in the next section I'll show you when you could use that rule to simplify an equation. Okay, so it's basically you take an exponent, bring it out front. Let's take a look at this one. Now this one, I've got more than just an exponent in it. Maybe because I'm dividing, why don't we use the quotient law to separate that out? So it'd be a squared minus log base a of 8. Now here I've got an exponent. I can bring that out to the front. So that would just be 2. And log base a of a is just 1. So it would just be 2. This whole thing would just be equal to 2 minus log base a of 8. Okay, this next one, I think I'm going to have to use the product law to separate this out a little bit. So let's do that. So log 24 plus log a squared plus log b cubed. Notice there's no base here, so we assume the base to be 10, but I don't have to write it in. Let's just leave the 24 for a second and do the rest. So this is the power law. I can bring this out front. So that'd be 2 times the log of a plus, and this one would be 3 times the log of b. Now, 24, I think I can simplify that a little bit. Let's rewrite it as, say, 8 times 3 plus all this other stuff. And log of 8 times 3, I could separate that. So it'd be log of 8 plus log of 3 plus all that other stuff I had, plus log of b. And then the 8 is the same thing as 2 cubed. You see where I'm going there? And I'll write everything else out. Plus 3 log b. So then I can use that power rule to bring that out front.
So the total simplification of this will be 3 log of 2 plus log base 3 or base 10 of 3 plus 2 log base 10 of a plus 3 log base 10 of b. Okay, why don't you try a couple? Try these two.
Press pause and play. So there's 2 I can bring out front. So this first one would just be 2 log of x. Done. 2 times the log of x. The next one, there's a quotient there, so why don't we use the quotient rule first? So 16, a to the 4th minus log of b cubed. Now, I'd like to take that 4 out front, but I'm multiplying the 16 by a to the 4th, so I maybe should wait on that. Why don't we use the product law on that one so we can separate them up? So it'd be log of 16 plus the log of a to the 4th minus all that other stuff. Now I could bring this 4 out to the front. So it'd be 4 log a minus log b, and then at the front there, log of 16. But 16, I'm thinking I could simplify that too, because 16 is 2 to the 4th. And again, I could bring the 4 out front. So this would be 4 times the log of 2 plus 4 log a minus log b. Okay, hopefully you got that. If you got to this point, that's good. Or if you got, oh, what happened to my 3? I didn't bring that 3 out front. I should have put the 3 right there and right there. I left a space for it. Hopefully you get the idea for this kind of simplification. Now, a couple other miscellaneous laws, and we've seen them already. If this base and this base are the same, then the answer to that whole thing is just x. So if I had log of star to the fourth, the answer would just be 4. So if these two things match, done. Similarly, here on the bottom, if I have a base raised to a logarithm and this base is the same, if those two are the same, your answer is just x. So say I had 7 log base 7 of z. So this and this match, so my answer is just z. The other one that seems a little funny is that log base a of 1 is equal to 0. So to what exponent must you raise a to get 1? And the answer to that's always 0. So you could have log base star of 1, your answer would be 0. Okay, here's just a nice little application of this kind of thing where I'm trying to simplify some expression where I don't know what the log is, and I'm trying to simplify it using some numbers that they have up here. So some known numbers. So they say log base b of 2 is as this, b, or 3 and 5. So the trick is to try and figure out what things multiplied together give you 90 that include 3, 5, and 2. So let's see, log base b of, if I went, say, 3 times 3, that's 9, times 5, 9 times 5 is 45, times 2. That'd do it for me right there. So log base b of 3 times 3 times 5 times 2, that gives me 90. Now, I could write it like that, or I could simplify it just a little bit and call that 3 squared times 5 times 2. And then I'd use the product rule to separate that up. So I'd have log base b of 3 squared plus log base b of 5 plus log base b of 2. Now, this first one, I could use the power law to bring that out front. So it'd be 2 times log base b of 3 plus all this other stuff, log base b of 2. Now I could go up to the top there and take a look and say, well, log base b of 3 is right there. So this answer would be 2 times 1.099 plus log base b of 5 is right there, 1.609 plus log base b of 2 right up here, 0.693. Now I just have to add that in my calculator and come up with my answer. Why don't you try one or two? Try these, see what you do. So 40, I would get log base c, well, that's just 5 times 8. 5 times 8. So it'd be log base c of 5 plus log base c of 8. But log base c of 5 is 0.8271. Log base c of 8 is 1.0686. So if I add those together, it's going to be 1.89 something or other. You can add them. 80, I could do the same thing. It's actually this thing just times by 2, right? So it's log base c of 2 times 5 times 8. And then you would just do the same thing. Okay, so I hope you got the idea of using properties of logarithms to help you simplify or re-express logarithmic expressions. We're going to be using these in the next section when we try and solve logarithmic equations. All right, try the video quiz, try the homework, try the other quiz. If you have questions, give me a call.